Hi everyone, I'm Zhang Shanhu from National Taiwan University. This is a joint paper with Josie E. Chen and Wei-Jian Chen, titled Will It Be Seen? Using Eye Tracking to Re-examine the Future Tense Effect in Intertemporal Choices. We will use the 15 minutes for the presentation and left 5 minutes for the QA. Here is the introduction. We want to examine the causal effect of the future tense on intertemporal preference. We use the future tense in the treatment group and do not use the future tense in the control group. It is a between-subject design. And our contribution follows the neuroeconomics approach, which we use eye tracking and drift division model to study the process behind the intertemporal choices. Because of the time limit, we will introduce the drift division model today. Here is the results preview. We found that the treatment group with the future tense chose 12.5% fewer later larger payments and spent 8.8% longer response time than the control group. And we use DDM to estimate the parameters behind the decision-making process. We found that future tense influence the process in two ways. The first is that future tense shifts people's preference toward the sooner smaller payment through the weight on time delay and the starting point. Second, future tense raises people's decision threshold, and thus people will spend more time to deliberate the choices. Here is the hypothesis behind our study. It is called Linguistic Savings Hypothesis, LSH. It is proposed by Keith Chen 2013. Basically says that the future tense will distance the future events, leading to less future-oriented behaviors such as savings. There are several empirical evidence using cross-cultural analysis supporting this idea. However, the correlations found in these studies could be driven by culture rather than by the language itself. Thus, there are some researchers using experiments to find the causal effect. However, there are conflicting results in the literature. Some researchers find supporting evidence while some don't. Therefore, in our study, we aim to uncover the cognitive and computational process behind the LSH and reconcile these studies. Here is the method we use. We asked subjects 112 binary choices between a smaller sooner reward, we call it early payment EP, and a larger later reward, we call it delayed payment DP. We will fix the amount of early payment, and we will vary the amount and the delay of the delayed payment across different trials. And we embed our linguistic treatment in the description of the delayed payment. We use the advantage of Chinese that the future tense is arbitrary in use. We use the future tense in the treatment group, which we frame it as after 1 month, will receive more than $100. And in the control group, we use a comma to replace the future tense word will in the same position. So the control group looks like after 1 month, receive more than $100. And we predict that according to linguistic saving hypothesis, the repeated use of future tense will distance the future event, leading the delayed payment is less attractive than the early payment. So the subjects in the treatment group will choose less delayed payment than the control group. Here is how we present the treatment to the subjects. The left-hand side is for the treatment group, the right-hand side is for the control group. The crucial difference between two is the future tense will is used in the treatment group, and we replace it with a comma in the control group. And from now on, we will talk about our subjects, procedure, and our results. We recruit 73 subjects in National Taiwan University. All of them are native Chinese speakers, and we randomly assign them into the treatment group or the control group. Among all subjects, 43% were female and 90% were economics majors. There are no significant differences between two groups, so our sample size is balanced. First, let we look at the descriptive of the delayed payment chosen by groups. The blue bar is for the control group and the red bar is for the treatment group. As you can see, the subjects in the treatment group choose fewer delayed payment than the subjects in the control group. This is consistent with the LSH, but the effect is not significant. We also look at the response time data. The blue bar is for the control group, the red bar is for the treatment group. As you can see, the subjects in the treatment group spend more time on deliberating the choices than the subjects in the control group, and the difference is significant. To account for both the choice outcome we see and the response data we observe, we utilize the drift diffusion model, DDM. DDM is widely used in psychology, while recent studies also apply it to intertemporal choices and other economic decisions. Here we introduce how the DDM works for the intertemporal choices. The first thing you have to know is that DDM assumes the decision process is dynamic and stochastic. Consider a pair of early payment and delayed payment. Decision makers will gradually accumulate their relative decision value, RDV, until the RDV reach a decision threshold. We set the positive threshold for the delayed payment and the negative threshold for the early payment. So the drift diffusion process will look like this graph. The dark, the black line is the RDV accumulation process. You will accumulate it from the starting point and towards the delayed payment because the drift rate is positive. And this graph basically shows that the subjects prefer the delayed payment and early payment. And when the RDV reach the positive threshold for the delayed payment, the subjects will choose delayed payment and spend this time. You also can view the diffusion process as a random walk with drift. So the epsilon t captures the noise in the diffusion process, and this can explain why subjects will choose inconsistency sometimes. And the v is the drift rate, which accounts for the speed of the accumulating process. And we specify the drift rate as a function of payment difference, the delay payment amount minus the early payment amount, and v also a function of time delayed. We also use a graph to show this. So you can imagine that if the delay payment for this trial is more fruitful, the subjects will have a higher drift rate, like the red line. So the subject will choose the delay payment more quickly. And if the delay payment is not so fruitful, the subjects might prefer early payment, like the green line. So the subject might choose the early payment. So the payment difference and the time delay will influence the drift rate. And also, subject parameters WP, the weight for the payment difference, and WT, the weight for the time delay, will also decide what is the drift rate in this trial for this subject. And we use the HDDM to estimate good parameters for the treatment group and the control group. And we wonder that whether future tense will affect these parameters in the DDM models. And we found that there is no significant difference between the treatment group and the control group in the weight of payment difference. However, we found that the subjects in the treatment group weighs the time delay stronger than those in the control group. And this results a preference toward early payment. It is shown in the graph. The treatment group of the weight on the time delay for the treatment group is the green curve, and the weight of time delay for the control group is the rate curve. So the absolute value for the weight on time delay for the treatment group is larger than those in that for the control group. And this is consistent that the future tense will distance the future effects. Second, we will introduce another parameters in the DDM, which is the threshold A. Basically, these parameters capture the level of caution. If subject raises a threshold, it will not choose and it will choose more consistently, more accurate to his preference, but it will spend more time to reach a decision threshold. So it will spend more time on decision. So we also use the HDDM to estimate the parameters for the treatment group and the control group. And we found that the threshold for the treatment group is larger than the threshold in the control group. So the orange curve is for the control group and the blue curve is for the treatment group. And this is evidence that the future tense will make the future events further, and thus the subjects will raise their level of caution. Lastly, the DDM also allows the starting point bias to one option. If the subject is present bias, like the green line here, it will choose the early payment more often and more quickly. And if the subject is future biased, the subject will choose the delay payments more often and more quickly. And we also find that the future tense will move the starting points for the treatment group towards the early payment, which is also consistent with the LSH. Okay, so we found that the future tense indeed influence the decision process behind our treatment, but we do not find the choice outcome to be significant. There are two possible reasons here. The first one is that maybe higher level caution offset the effect of the starting point bias, or maybe that the effect is too small for our sample size to detect. So to figure out this, we run some simulations. We use the DDM parameters to simulate hypothetical subjects in n equals to 100, 600, and 1000. And as you can see in the graph, the treatment effect is detectable under alpha equals to 0.1 when the number exceeds 1000. Thus, it is unfeasible for our sample size to detect the effect. Given that our manipulation is relatively weak, we just change one word in Chinese. We still find the future tense affects the decision process. However, if you want to find the change in outcome, you need sufficient subjects to do that. And this reconcile and explain why there are conflicting results in the literature, and shed light on the importance of modeling the dynamics of the choice process. And this is my presentation. Welcome any comments and questions. Thank you.